Hello students, welcome to another session of this relations and functions, and in this session we will be dealing with some of the important problems on on-one, onto and bijective functions. So let's start. So here is the first example. State whether the function is one-one, onto or bijective, and you have to justify your answer. From the point of examination, I expect one question from this, definitely this time. Okay, so you need to show whether it is a one-one or onto, and if it is both one-one and onto, we call it as a bijective. So ಏನೆಲ್ಲ ಆಗುತ್ತೆ ಚೆಕ್ ಮಾಡೋಣ ಇಲ್ಲಿ. So what it is given is, first you need to write given. Given your function is given as 3 minus 4x, and domain is also R and codomain is also R, set of real numbers. Okay, now for oneness, whether it is one or not. So for one you need to consider two elements belonging to domain are such that, consider two elements x1 x2 belongs to R such that f of x1 equals to f of x2. Okay, and you need to show that x1 is equal to x2, you have to show. If that implies, then the function is said to be one that I told in the beginning. So this implies f of x1 andre ಏನು, according to this, fx andre 3 minus 4x ಇದೆ, f of x1 is, it's a 3 minus 4x1. On the other side, it is 3 minus 4x2. Okay, this implies 3 cancels, minus 4x1 is equal to minus 4x2. You can divide both sides by minus 4. You left with x1 is equals to x2. Okay, so it implies that according to the definition, this implies that given f is 1 function. So this is how to prove whether given function is 1 or not. Okay, so consider f of x1 is equal to f of x2, and you have to show that x1 is equals to x2. Now we have to check whether it is onto or not. So for ontoness, consider for onto, you have to consider what is ontoness is. When do you say that the function is onto? Every element of codomain must be image of some elements of the domain. So that is why one arbitrary element anna consider ಮಾಡಿ. Consider any arbitrary element y belongs to the codomain. You have to take one element from the codomain. Okay, how it should be? You suppose that consider y belongs to R such that f of x is equals to y, means y is the image of some element of x in the domain that you have to search. Okay, now this implies, according to the definition, fx is, it is a 3 minus 4x equals to y. Now we have to search for y, means find, so search for x. So minus 4x is equals to y minus 3 this implies x equals to y minus 3 by minus 4. Now what does it imply? Here, if you give any real number, you have taken y from the real number. If you give any real number, does this relation provide you any other real number? Exactly. So what should I write it? This belongs to, means x belongs to, this will remain in the domain for any y. This belongs to, if you substitute any real number for y, then the result will be in domain. So that you have to write like this. So this belongs to R for all y belongs to codomain R. So this implies, what does it imply? For every y belongs to R, there exists some x belongs to R. That is the meaning. So in this way, you have to prove that whether the given function is onto or not. So this implies given f of x is onto. So it is bijective. Hence f of x is bijective function. Okay, so the function which is both 1 1 and onto is said to be bijective. So in this way, you have to prove 1 1 and onto. Let's have another example. So similar example, consider a function f from R to R given by f of x is equal to 4x plus 3. Show that f is bijective. Okay, so similar thing you need to do. As usual, given f of x is equals to 4x plus 3. So for 1 1, you need to consider 2 elements x1 x2 belonging to the domain R. Okay, you have to consider 2 elements from the domain such that f of x1 equals to f of x2. Assume that their images are equal. Now you have to show that x1 is equal to x2. So this implies 4x1 plus 3 is equal to 4x2 plus 3. Okay. So 4x1 is equals to 4x2 because 3 get cancels. Now divide by 4 get cancels. This implies x1 equals to x2. Therefore, f of x is 1 1 function. Very easily you can prove this. Now, as earlier, you can prove whether it is onto or not. Okay. For onto, you have to take one arbitrary element from the codomain. So consider any y belonging to codomain. Okay, now you have to show that for this y there exists some x in domain. Okay, so consider for any y belongs to R, f of x is equals to y. Okay, means y is the image of x. Now you have to search whether that x is in R. So according to definition, it is 4x plus 3 is equals to y. 4x is equals to y minus 3. Very simple. X is equals to y minus 3 by 4. Okay. Now the important thing is you have to show that whether it belongs to the domain or not. Okay. So y is what? Y andre ಒಂದು real number ಇದೆ. Okay. ಸೊ ಏನೇ ರಿಯಲ್ ನಂಬರ್ ಹಾಕಿದ್ರೆ ಬರ್ತಕ್ಕಂಥ ರಿಸಲ್ಟು ಮತ್ತೆ ವಾಪಸ್ ಡೊಮೇನ್ಗೆ ಸೇರುತ್ತಾ ಅಂತ ಡೆಫಿನೆಟ್ ಆಗಿ ಓಕೆ ನೀವು ಏನೇ ರಿಯಲ್ ನಂಬರ್ ಕೊಡಿ ಓಕೆ ಸೊ ಯು ವಿಲ್ ಗೆಟ್ ಸಮಥಿಂಗ್ ಯು ವಿಲ್ ಗೆಟ್ ಸಮ್ ರಿಯಲ್ ನಂಬರ್ ಸೊ ದಟ್ ಈಸ್ ವಾಟ್ ದಿಸ್ ಬಿಲಾಂಗಿಂಗ್ಸ್ ಟು ಆರ್ is what? It's a domain. You have to show that x is in the domain. This belongs to R for what? For all y belongs to R. Okay, codomain. So this implies this y is codomain, from the codomain. You take any value from the codomain, and if you substitute it here, you will get some real number that belongs to R. Okay. So this implies f of x is onto function. Hence, it is bisective function. Okay, so very simple, 5 marks gettable. Okay, let's have another example. Now here is the example. A is a given set of all real numbers except 3, and B is a set of all real numbers except 1, and the function is given f from A to B defined by f of x equal to x minus 2 by x minus 3. You are asked, is f is 1 1 on to justify your answer. Okay, so given domain is set A, and A is given as R minus 3. Codomain is given as B, and it is R minus 1, and your function is given x minus 2 by x minus. Okay. So for 1 1, for 1 1, consider any two elements x1 x2 belongings to the domain A. Okay, so you have to consider two elements from the domain A such that their images are same, such that f of x1 equal to f of x2. Okay, now you have to show that corresponding elements are equal. That means x1 is equal to x2 you have to prove. So according to definition, this becomes x1 minus 2 by x2 minus 3 is equals to, sorry, it is x1 minus 3 equals to x2 minus 2 by x2 minus 3. Now simplify it, cross multiply x1 minus 2 into x2 minus 3 is equals to x1 minus 3 into x2 minus, to bring this side, which implies multiply these two. Okay, x1 into x2 is x1 x2 minus x1 into minus 3 is, that is 3 is 3x1 minus 2x2 and minus into minus plus 6. On the other side, x1 into x2, x1 x2 minus 2x1 minus 3x2 plus 6. Okay, so simple. Now you can remove the common term that's exists in both the sides. x1 x2 x1 x2 cancels, 6 plus 6 plus 6 cancels. Okay, now you want to bring x1 x2 one side, that's x1 x1 and x2 x2 on the other side. So it is minus 3x1 plus 2x1. Bring this 2x1 this side. On the other side, minus 3x2, and you can bring this 2x2 this side, it becomes plus 2x2. That gives you minus x1 equal to minus x2, or you can write x1 is equals to x2. So this implies f of x is an 1 1 1 1 function. Okay, so for onto, consider as earlier, for any y belongs to codomain, you have to consider any arbitrary element from the codomain. Consider for any y belongs to B, f of x equals to y. Now you have to find x in the domain. So this implies what it is given, x minus 2 by x minus 3 equals to y, which implies x minus 2 is equals to y into x minus 3. We have to find x. X minus 2 is equals to xy minus 3y. Okay, multiply this. Now bring x term this side. X minus xy is equals to, bring this minus to this side, it becomes plus 2 minus 3y. From this you can take x common, because our aim is to find x. 2 minus 3. So this implies x equals to 2 minus 3 by 3y by 1 minus y. Now you have to show that whether this x is in the domain or not. Now clear. What is codomains here? Y you have taken from the set B, and B is what? B is a set consisting set of all real numbers except 1. So in the set B we don't have 1. So y can never be 1. Okay. So this can never be 1. So this will not be infinity for any y. So that is what it belongs to domain. Okay. If you put any value for y from the codomain, you will get some value in the domain. So this is for what? For all y belongs to B. Okay, if you take any value from B and if you substitute here, so you will get some value in the domain. So it means what? For every y that belongs to B will have some x in A. That is the meaning. So this implies f of x is onto. Hence, it is bisective function. Okay, so in this way you have to prove. Let's have another. Show that the function f from r star to r star defined by fx is equal to 1 by x is 1 1 and onto, where r star is the set of all non-zero real numbers. Okay, r star means set of all non-zero real numbers, means r star is nothing but it is r minus 0, set consisting of all real numbers except 0. Now you have to show that whether it is 1 1 or on 2. So you are asked to show. So given f of x equals to 1 by x. Okay, so this is domain as well as codomain. So consider for 1 1. For 1 1, consider x1 x2 belongings to r star such that f of x1 equals to f of x2. So this implies 1 by x1 is equal to 1 by x2. Simple one. If you take reciprocal, this implies x1 equals to x2. So hence f of x is 1 1. Okay, so now for onto. For onto, consider for any y belongings to codomain is also r star. For any y belongings to r star, how it is f of x equals to y. So this implies 1 by x is equals to y. This implies taking reciprocal x is equals to 1 by y. And as y can never be 0 because y belongs to r star. R star is set of all non-zero real numbers. So definitely for any y, this is again a element in the codomain. Okay, so this belongs to r star for all or for any y belongs to r star. So hence f of x is, or it is on 2. Thus you can mention f of x is a bijective function. Bijective function. Now see here further what it is asked. Now further question is there, is the result true if the domain r star is replaced by set of natural numbers? Look here, if R star is replaced by n with codomain being same. Codomain same and domain is n. Okay. Now if it is 1 1, if you take x1 x2 belongs to n, so x1 equal to x2 it will have imply. But for ontoness in the interval, okay, look here, if domain is equals to n and codomain is equals to R star, then for ontoness here, if we consider for any y belongs to R star, such that f of x equals to y, what does it imply? 1 by x is equals to y, and which implies x is equals to 1 by y. Now see here, your x is what? You have to show that whether it belongs to domain. Clearly it does not belong to the domain for any real, non-zero real number. If you have taken y from the R star. So suppose if you give y as 2, you will get 1 by 2, and 1 by 2 is not a natural number. So this implies 1 by y does not belong to domain for all y belongs to codomain. So this implies f of x is not onto, okay, with domain as set of natural numbers and codomain as this. So this is to be noted. Okay, so these are the few examples from 1 1 and onto. So in the next class we will be dealing with 1 1 and onto nature of some standard common functions, that is a modulus function, sinum function, greatest integer function, and many more things. So let's meet in the next session.